Hi all, in this video I'm going to work through creating my first pipeline in DocWrangler. DocWrangler is this project that is coming out of UC Berkeley, led by Shreya Shankar, and it's a system for agentic LLM-powered data processing and ETL. And DocETL is the engine on the back end, and then DocWrangler is the UI on the front end that allows you to access the capabilities of the underlying engine. So this is the first time I've done a video on DocWrangler, so we'll see how it goes. I have a tweet thread where I already showed my first attempt at this pipeline with screenshots, so I'll link that in the video description, and we'll see if I can at least mostly recreate that pipeline here. So a couple of things to start. To install DocWrangler, I cloned the repo, and then I did a couple of things as they have in the documentation. I set the .env file in the root directory, and they have a helpful sample here, .env.example. And then in the website directory, I set a .env.local, and they have an example for that as well. And once that happened, I followed the instructions down here. I did ran make docker, and I already have Docker desktop installed, so I made sure I opened that first. So Docker was running, and then make docker runs it. The image it creates is about 15 gigabytes, so make sure you have about 30 or so gigabytes available on your disk. And once it runs the make docker, it takes, I don't know, 5 or 6 minutes, maybe a little longer. It will expose the UI at port 3000. And so that's what I'm looking at here. You open localhost 3000, you click on Playground, and then it brings you here. A couple of features that I set. So when you open this Playground, it asks you for a name for your kind of like workspace. So I set that name here. You can edit this name here. So I set it as DocWrangler paper summary. So that's what I'm going to do in this pipeline. I'm going to take the PDF from the DocWrangler paper, the Steering Semantic Data Processing with DocWrangler paper, Shreya Shankar et al. And I'm going to create a pipeline to extract the main takeaways from the paper. The reason I'm doing this is, one, it's one document, so it's much more manageable in scope. And two is I already did a summary of the DocWrangler paper, so I've read it 1 or 2 times, and I've already gone through, highlighted my main points, and I've written this blog post that I will link in the video description below. This blog post is a little different from most of my paper summaries. Usually when I do a paper summary, it's kind of in a conversational tone, but it's still very much focused on the technical details. This time what I did was I connected what I was reading with my experience in data analysis and with LLMs. So it's a much more conversational, a lot more commentary, and hopefully it's a style that resonates with folks. It certainly helped me connect my experiences with what I was reading in the paper. I also use these Quarto collapsible sections to put paper quotes. 2 reasons. One was it saves me space, and the second reason is I get to create these fun little titles for each of the quotes. So that blog post is linked in the video description. But the main point I'm trying to emphasize by sharing that blog post is, well, yes, of course, I would love it if you read it and if it was useful to you. But 2, I'm using this paper as the pipeline document because I'm already very familiar with it. I've read it, I've processed it, I've written about it. So I feel very comfortable with the data. So in that sense, when it comes to extracting takeaways from the paper, I consider myself a domain expert. I'm not a domain expert on the contents of the paper, but I feel like I have domain knowledge about extracting takeaways, which is the task that I'm asking the LLM to do. And this resonates with uh, what Hamil Hussein and Shreya Shankar teach us in the AI evals course, which is you should always have a domain expert look at the data so that they can judge whether the LLM outputs are accurate. Okay, so let's get into it. Uh, First thing we're going to do is we're going to go to this files section and click on this upload arrow, and I'm going to say upload files or folder. I don't have a local server running, but they do have this option of running the DocLing server. And if we open up DocLing, this is not a project I was familiar with, and it seems really awesome, and it's very popular. It's a document processing, parsing diverse formats, including advanced PDF understanding, providing seamless integrations with the Gen AI ecosystem. So cool project. Glad that I'm now aware of it. So I'm going to use their hosted server, which is going to be slow but more accurate, processing across many documents. I only have one document, so I don't care about time. Supported formats for documents is PDF, DocX, Doc, Text, HTML, PPTX, and MD, Markdown. So I already have the PDF downloaded. So we're going to attach it here. It's 6 megabytes. And I'm going to hit convert. This is going to take a minute, so I will just fast forward this part and restart the video once it's done. Okay, so that took about 2 minutes or so. It is a 18-page PDF. So it has this converted directory. It has the original PDF, and then it has this JSON file. So if I go up here to the right, I can click on toggle dataset view, and I can expand this panel, and I can see that here is the entire paper text converted into a JSON file. Here's the file path. The body of the paper, or all the contents of the paper, is in this markdown key. Here's the file name, and then there's one JSON object, and there's one item in this list. I can go to available keys. I can see file name, markdown, file path. And if I look at dataset statistics, there's one document, and it's 15,295 words. So that gives me a sense of how much data we're processing. All right, so I think that's everything I wanted to talk about in terms of data. What I'm going to do now is I'm going to add an operation, and we're going to do a map operation. This transforms each input item for complex data processing and insight extraction. One-to-one operation. Each document gets one result, but the output of the operation can be any type, like a list. So that's what I want to do. I'm going to call this main takeaways, and I'm going to enter a prompt. This is a very kind of naive prompt. I already know that this is most likely not going to give me what I want, but it's a good starting point. And what I'm going to say is I would like to extract 5 main takeaways from the document content specified below. So let's just try that. And then input is the name of the object that this receives, which is each of these dictionaries. And then markdown is the name of the key that has the content that I want to process. So, obviously not a great prompt, but that's partly intentional. And then let's say main takeaways is going to be the output key. and this is going to be a list of strings. And that's it. Let's see if it runs. And it's running. And I'll probably pause the video while it runs so we don't have to watch the progress. Oh, that was fast. All right, so let's take a look. Let's see, how do I... Here we go. All right, let's bump this up. So it has given me one output, and the array has 5 items, which is good. And here are the takeaways. DocWrangler is a mixed initiative IDE for semantic data processing that leverages large language models to facilitate handling unstructured text. Yes, that's true. The system introduces 3 novel features: in situ user notes for seamless annotation and tracking of observations, LLM-assisted prompt refinement that enhances user prompts based on their notes, and LLM-assisted operation decomposition to break down complex tasks for better execution. The evaluation of DocWrangler through a user study showed participants successfully developed strategies for semantic data processing, often repurposing LLM outputs to aid validation and decision-making. The design emphasizes bridging cognitive gulfs between user intent, pipeline specification, and data comprehension, and allows iterative improvement of the analytical task based on insights gained from LLM interactions. The system has been deployed publicly, demonstrating its utility across diverse domains, and it collects telemetry data that reveals common usage patterns and the effectiveness of AI assistance features. This is pretty good. You know, this covers a lot of the main topics, but I think I have 2 complaints about this, and I'm going to add that in this notes section here. I'll start by saying that overall this looks okay. The first complaint I have is that this is not easy for me to validate. I'm already familiar with the paper, so I can tell that these are correct, but it would be difficult for someone not as familiar to make that validation. And I would want to use this pipeline for a paper that I don't know, and this is not easy to validate because 18 pages have been condensed down to 5 data points. The second complaint that I have is that while this is a really good overview, it's missing some details. So for example, they mention the cognitive gulfs, but they don't explicitly, the LLM doesn't explicitly list what those 3 gulfs are. And they mention usage patterns, but they don't mention any specific usage patterns. So I would like some more detail, and again, that's probably a result of asking the LLM to summarize 18 pages into 5 takeaways. So there we go. Here is my note. So I'm going to click Add Note, and I'm going to close that. And now I can see, if we expand this a bit, here's my note. It was voice dictated. And you can see that it corresponds to the main takeaway columns where it had these 5 takeaways as a list. And then I can delete that note if I no longer want to use it. So these are the in situ notes that they talk about in the paper. Okay, so I have a working prompt. I have some pretty good takeaways, and then I have some feedback. So what I want to do now is I want to improve the prompt based on this, and I want to improve the pipeline based on this process. So I'm not going to click on Improve Prompt just yet, because what I'm going to do is I'm going to add an operation. And what I'm going to do here, I actually don't know if you can reorder operations, so let's try that. So I'm going to do a non-LLM operation, which is a split. I'm going to divide the documents into multiple parts based on specified criteria, creating new documents for each part. So part of my complaint was that the takeaways were too high level. And my guess is that it's because the context was too big. So what I'm going to do is I want to split the document. And let's move it up. So I'm just going to say split by markdown heading. And if we look at the raw text, here's a second level markdown heading, abstract, here's another second level heading, CCS concepts, second level, introduction, second level. We keep going down. Let's see. Actually, let's do a search. Nice. Let's do this. Search. I don't know why it's not searching. Oh, minimum 5 characters. Okay, that's why. So yeah, I think it's fair to say, at least here we go. Here's section 3. So yeah, I think we're gonna split by the second level markdown heading. So split key is gonna be markdown. I'm gonna say delimiter, and the delimiter is gonna be pound pound. Okay, so I think that's good. So I'm actually going to keep this prompt. Let me see. I'm kind of deviating from the first pipeline that I did, but I guess that's fine. Let me see if the LLM can improve the prompt, but I kind of want to do the split first. So we're going to improve the prompt later. So let's see. I'm going to skip operation. That's not something I just realized that's a thing, so that's cool. So let me just split and let me look at the outputs. So I'm going to run this. Cool. So this took in one document and it made 24 chunks. And if we look at the chunks, let's look at this a little closer. It creates markdown chunk. So here's the first chunk. Here's the abstract, CCS concepts, keywords, introduction, related work. Yeah, so this looks pretty good. This has broken up all the sections, and it looks like it's covered all the sections. Acknowledgements, references, appendix. Cool. So this looks good. So I'm going to keep that operation. And here I'm going to now include operation, keeping my original prompt, except the key is now I'm going to do markdown chunk. So I would like to extract 5 main takeaways from the document chunk content specified below. And let's call this chunk takeaways. It's still a list of strings. All right, let's run this. So here we see the progress. All right, let's take a look. Okay, so I'm going to open the markdown chunk on the right-hand side. So this is the kind of title and first figure. And then I'm going to look at this array here, and I'm going to take notes where necessary. So DocWrangler enhances semantic data processing by facilitating user interaction with their data and LLM calls. So that is that seems related to this, I think. And it introduces 3 main features. That is here. In situ notes bridge the gulf of comprehension, LLM assisted prompt, gulf of specification, and then generalization by operation decomposition. So it's a bit verbose. These 4 could be combined into just this one sentence. So what I'll say is the LLM is unnecessarily breaking up one sentence into 4 takeaways. I think I want it to just, at this stage, use extract verbatim the takeaways from the chunk. So let's add that note. Okay. Let's go to the next one. This is the abstract. Now this is a bit longer. Unstructured text analysis has improved with the advent. So that's kind of combining this, allowing for semantic data processing, which is like this thing here. Instead of traditional data pipelines. Kind of. I mean, it's here powered by LLMs instead of code. Yeah, this is a bit paraphrased, which is fine, but it's like at this stage, because I know I'm not going to keep these 5 items per chunk, right? Because 5 times 24, that gives me 120 takeaways, right? So eventually I'm going to reduce that down to, whatever, 5 or 10 takeaways. So at this stage, I don't really need it to summarize. So let's just make that point. At this stage in the pipeline, I don't need it to summarize or paraphrase. I would just like to see verbatim takeaways extracted from the chunk so that I can more easily validate the takeaways extracted. All right, let's add that note. Let's look at a couple more. I'm pretty sure the pattern is going to repeat. Yeah, this is interesting. So this is very condensed, right? So now it's like expanding this into sentences. Another example where it just needs to extract verbatim text. It's expanding keyword concepts into full sentences. It also seems to be forcing 5 takeaways when 2 would be sufficient or 3 would be sufficient in this chunk. Yeah, same thing here. Same thing here as the CCS concepts. The keywords are unnecessarily expanded and there's hallucinations taking place because the LLM is trying to force 5 takeaways. One thing I'm thinking about is like I have inspected 4 data set items or 4 LLM outputs, and 2 of them are like very fringe chunks, like the keywords and the CCS concepts. So I don't want to overly emphasize those notes, so I'm going to do a few more. Okay, unstructured documents. That seems this chunk here. Notoriously difficult, present challenges, so there's some difference there. To analyze automatically. Typically, traditional data analysis systems typically operate on structured data. So it's kind of combined all that into one sentence. LLMs offer a new approach, present a new way forward through semantic data processing. Effective semantic data processing. So let's see if that's effective semantic data processing involves 3 components. The user, their pipeline, and the data. Yeah, this is not correct because I would like it to include all 3. Instead, it just says user interactions with LLM operations and unstructured data. That's not quite what this is saying. So I'll say this is another example where the second takeaway about effective semantic data processing is paraphrased to a point where it loses the original meaning of the text. And so I definitely want, at this stage, the LLM to extract the verbatim text and not paraphrase. Okay, let's look at one more. And also really cool that you can search here. That makes data validation a lot easier. Semantic data processing systems. Let's look at one of these. Black box. That should be a LLMs offer. They provide entirely new black box capabilities. This creates a new challenge. LLM behavior is uncertain and context dependent. Effective interfaces must therefore enable refinement of both the pipeline structure and individual operations while keeping data continuously visible throughout the process. The LLM has kind of condensed all of that into this black box capabilities, complicating workflows. Interfaces must support continuous refinement and visibility during processing, which is pretty good. But I would like to see this detail about pipeline structure and individual operations kept. Another example of where I would like to see the verbatim takeaway text used instead of paraphrasing by the LLM. All right, I think that's pretty good for now. So I'm going to close this. And if we look at my notes, now I have multiple notes. So this one here where I was talking about missing some details, I think I already addressed that with the split operation, which is a non-LLM operation. So I'm going to delete that. So I'm just going to keep the 6 LLM output notes here. Okay, so now we can do the improve prompt. And this is really cool because it shows my current prompt and it shows my notes. And the additional instructions I want to add is that, well, I think it's okay. Like this idea of it doesn't need to force 5 takeaways, I think is generally applicable. So I think that's fine. One thing I'll do here is I'll say use personal OpenAI API key. So let's say continue to analysis. And so shortly, it should, there we go. Your feedback highlights the need for the LLM to extract verbatim takeaways without summarization or paraphrasing and to focus on a more flexible number of takeaways based on the content. Here's an improved prompt that incorporates your feedback and adheres to best practices. This revised prompt is specific, breaks down the task into clear steps, provides an example output format, and maintains focus on verbatim extraction as per your feedback. So instead of 5 main takeaways, it's the main takeaways. This is fine. It's the same. Extract verbatim text from the chunk without summarizing or paraphrasing. Focus on capturing the essence of the content as it is presented without expanding keywords into full sentences. Hold on, let's directly edit. So I don't need that. That was like only 2 chunks, so if it does that for those 2, like who cares? Provide 2 to 5 key takeaways. If the content supports fewer than 5 takeaways, feel free to provide only the relevant ones. Format each takeaway as a bullet point for clarity. No, I don't think I need that. I don't need a bullet point. So we just need, and I don't need this like takeaway 1. So let's just say, let's just do this. Takeaway 1 text, takeaway 2 text, takeaway 3 text. Oops. So this will help me validate the takeaway extracted more easily with the source markdown chunk. All right. I think I can just say save and overwrite. Save and keep notes. Let's keep notes for now. Um, Let me just make sure this did what I wanted it to. Yeah, so it kept those two. Let's see. Example output. Output schema is still a list of strings. All right, so now I think I can delete these. Delete. All right, so let's run this and see what it does. Okay, it's pretty quick. So chunk takeaways. Markdown chunk. All right, effective semantic data processing requires interaction between users, their pipeline of LLM calls, and their data, both raw documents and LLM outputs. Good, that is verbatim. DocWrangler contributes 3 novel features to address: A, the gulf of comprehension; B, the gulf of specification; and C, the gulf of generalization. That is also verbatim. Cool. Let's go down a couple. And let's search now. So this should be verbatim or close to it. Processing systems focus on optimizing an inner computational loop that assumes well-specified tasks, clear evaluation metrics, rarely begins, perfectly formed specifications. Let's look at this. Just copy this text. Okay, that looks pretty good. LLM as a judge, criteria. Prior work points to a clear challenge. Lack effective interfaces. Cool. So I think this is better. This is what I like to see. Let's do a couple more. Search this. Okay. Maybe we take the whole one. Search it. Nice. Okay. And let's do one more, maybe later in the paper. Participants pointed out limitations. So that's a good takeaway. Okay. Search this whole thing. All right, so it looks like that. Maybe I included the, let's see. Easier ways to trace how LM outputs were derived from the source text without having to manually search documents or write customs checks. Code-based filter after each map. Why didn't it not find that? Let's try it again. Okay, cool. So I think this looks pretty good. Just looking through all these to make sure that everything has takeaways. And it does. Okay, so I have no notes because I'm pretty happy with that. So now we're going to do the next step, and this is a reduce. So reduce operation aggregates data by key for summarization or folding. Many to one operation. Many documents get combined into one result. Yes, that is what I want to do. And then what I want to do here is I'm going to say unique takeaways. And let's see. I think it had, where did it show an example? I could have sworn there was something where it showed an example. Here we go. Operator guide. Yeah. So let's take a look at this. The reduce operation groups documents by a reduce key, like a SQL group by. Yeah, that makes sense. Then runs the prompt once per group. The reduce key can be one or more columns. Documents with the same values for these columns will be processed together. Use _all as the reduce key to process all documents in a single group. That's good. That's what I want. Each document of the group is available in the inputs list, and you can reference specific fields with dot notation. So this is what I want. Actually, this is what I want, reference specific fields. So I'm just going to copy this and paste that. And I'm going to say chunk takeaways, and it's going to be input chunk takeaways. So let's see, the prompt for this is going to be please summarize each document chunk's takeaways into a unique list of takeaways. There should be around 10 or so takeaways. Let's add some more detail. Remove duplicates and keep only unique takeaways. If 2 or 3 takeaways are related to the same concept, feel free to combine and paraphrase them. Okay. Not the greatest prompt, but I feel like the amount of information is so little that hopefully it should be sufficient. But if not, we will improve the prompt. All right, cool. So let's run this now. Oh, actually, hold on. Output schema. I'm going to say unique takeaways. And this is going to be a list of strings. Cool. Now let's run. All right, let's look. Okay, so let's look through each of the 10. DocWrangler is an integrated development environment designed for semantic data processing, enhancing user interaction with large language models. Good. Effective semantic data processing requires a deep understanding of the data and collaboration with LLMs through iterative pipelines. Nice. I like the iterative aspect. DocWrangler addresses 3 major gaps: comprehension through in-situ user notes, specification via LLM-assisted prompt refinement, and generalization using operation decomposition. That's great. It kind of combines the 3 gulfs and then the 3 features. Unstructured documents, such as PDFs and emails, present challenges for automation and analysis. Current systems need further development to optimize their effectiveness. Yeah, that's fine. Not the best one, but that's fine. User workflows in semantic data processing typically consist of initialization, processing, and validation phases, which can be cognitively demanding due to LLM unpredictability. That's good. I think it's the 3 I's framework. The system allows users to annotate observations and refine prompts while continuously visualizing data outputs across the pipelines. That's great. Users appreciate DocWrangler's support for diverse document analysis tasks, but they also highlight challenges in interpreting LLM outputs and request better tracking and visualization tools. That's a really good one. That definitely touches like 3 different kind of minor or separate takeaways into one. Pipeline construction remains a challenge as users often struggle to fully articulate their analytical intents. Flexibility in operation design aids in task adaptation. I'm not 100% sure what that means. Flexibility in operation design aids in task adaptation. It kind of makes me think of one of the takeaways they had in the user study findings, where they said something like optimizing the operation helped them better understand their problem. So I think that's what it's referring to. Participations indicated a preference for simplifying operations to aid validation, reflecting a broader need for automation in error checking and output evaluation. Yeah, that's good, I think. Future systems should focus on user-centered design that encourages epistemic reflection and integrates automated feedback mechanisms to improve the semantic data processing experience. So overall, I like these better. I think, I think the signal that I'm looking for is when I'm reading these, it makes me think of what are the lower level takeaways that are wrapped up into each one of these. So I think that's kind of the signal that I'm looking for. For example, um, the mixed initiative integrative development environment, the three gulfs, as well as the DocWrangler features that address the gulfs. Those are kind of wrapped into one. The uncertainty around LLMs, the let's see. I don't think this one was addressed. Yeah, they didn't really talk about the design goals. I don't think so. It talks about how it addresses the major gaps, but it doesn't really talk about the design goals. It kind of addresses them, right? It talks about the processing pipelines. It appreciates the support, flexibility in operation design. So yeah, I think there's some things that are still missing that I would like to have, but again, I didn't explicitly mention that in the prompt. And then yeah, the three features I already talked about that. So yeah, I think overall this is pretty good. I certainly like these more than the first 5 that it created. But let me do one last prompt improvement and see. And let's see, what do I want to say? Because I've read the paper, I can tell that there's a couple things that I would like to see. For example, there's 5 design goals that they state in the paper. I would like to see that because I think of that as a fundamental takeaway about what motivated their design, and it also ties to the user study findings. I would also like to see a couple more examples from the user study findings. Maybe there could be one more takeaway that combines 2 or 3 examples specifically of what users did in innovative ways while using DocWrangler and how DocWrangler allowed them or facilitated those things. So obviously, if I hadn't read the paper, I would read these takeaways and I would be like, okay, yeah, this is good. This is good enough. But I think having read the paper, I would like a little more. So I'm going to add that note, close it, and then I'm okay with everything before this, right? I'm okay with the split. I'm okay with the main takeaways. I just want to improve the unique takeaways. And let's see what it says. Oh, use personal key. Let's see what it says. Your current prompt provides a good foundation, but can be improved for clarity and specificity. Here's an analysis. The prompt should explicitly state the number of takeaways expected and the importance of including the 5 design goals and user study examples. Step-by-step instructions. Examples. Include examples of how to format the takeaways will guide the LLM. It was fine with the format. Clearly specify how the output should be structured. Providing context about design goals. So yeah, I think this is where you kind of blur the lines of vibe coding and domain knowledge, right? Or vibe knowledge and domain knowledge. If I hadn't read the paper, which is a use case for this pipeline, I wouldn't know to specify this. But since I have read it, I do want to specify this. So let's see what it says. Number of takeaways, aim for around 10. I think I'm going to make that 10 to 15. Remove duplicates. If 2 or 3 takeaways are... Okay, so it kind of just broke out my tasks into a bulleted list. Include specific content Okay, that's fair. You know, it's saying include 5 design goals, at least one key takeaway that combines 2 or 3 examples, and then output format. So I'm going to directly edit, and we're going to go back to this format and say extract takeaway 1 text or exact. I don't know why it says exact. I'm going to say unique takeaway 1, unique takeaway 2, unique takeaway 3, and then here I'm going to say 10 to 15. And we're going to say save and overwrite, and this time we are going to delete notes. All right. Yeah, I like that better. Okay, let's run it again. All right, let's look at these now. So the first one is the same. For the 5 design goals, address comprehension, specification, and generalization gaps. Yeah, that's okay. If we look at the 5 design goals, it's initialization, inspection. Yeah, so that's okay. It's not great, but it's okay. DocWrangler features in situ notes, refinement, operation decomposition. Yep, that looks good. Cognitive load, interfaces, highly usable, ease of management. Yeah, I like this one. So that's good. I'm glad that it included that. Adapting prompts and classifications based on LLM outputs to improve interpretability. That was definitely one of my takeaways from the user studies findings. That's good. Yeah, that's a good detail to add. That's definitely, I mean, we kind of saw that, right? Like, I had to ask the LLM to pull verbatim text so that I could search for it. You could argue that you don't have to have that requirement. You may want to have whatever text paraphrased, but it should cite it back to the source text. Where were we? We did this. Yep, validation. Common theme was automated eval methods, enhancing trust in LM outputs and reducing validation time. I don't recall that one, but well, kind of automated evaluation methods. That goes back to the tracing results, I think. And then innovative use. Yeah, and that's a good example. So I think that's it. Cool. So that is my pipeline, second pipeline, but first pipeline in terms of the document that I'm processing and the outputs that I'm getting. As a summary of what we did, I started with a very naive prompt. I gave it the entire document and said, give me 5 takeaways. I saw those takeaways, they were too high level. So then I performed a non-LLM operation of just splitting the markdown text by the second level heading. So that made 24. So if we look at show outputs, that made 24 chunks, abstract, introduction, etc. We then asked it to get takeaways from each of those 24 chunks, verbatim text, and it seemed to be doing that just fine. And then once we got verbatim text takeaways, then we said, okay, now you can paraphrase and summarize and give me 10 to 15 unique takeaways. So we went from, about 100 or so takeaways down to 10 to 15. Remove duplicates. It didn't have duplicates. That was good. It did combine related ones. It did include the specific ones. The 5 design goals were not explicitly stated. I would have liked that. Um, but maybe that's just my prompt, so maybe I could improve that. And then every time the output format was okay. And then we had to kind of look at the reduce operator guide, which is here, to look at the syntax for iterating on those fields. So I hope that was helpful as a introductory demo. I will certainly dig deeper into DocWrangler and DocETL and try it with more complex pipelines. But I think the main thing I want to highlight is it's really refreshing to see an interface that actually matches how you want to think about a problem and is not just a generic chatbot interface. So, highly recommend checking this out. Thanks for sticking around until the end, and I will see you next time.